Okay, this is Introduction to Statistical Learning. We're in Chapter 12, which is all about unsupervised learning. And we are in the conceptual questions, question number 2, which is dealing with hierarchical clustering. We will have parts A through E, and normally I break these out, but because they are so related, we will just kind of push through all of them in kind of a haphazard manner here. But we need to know what we're working with. So we have a distance matrix here, or a dissimilarity matrix that we will, where we will treat the values as distances between observations, and that is given here. What do we want to know about this? So notice that this encodes 4 different observations, right? So this is the dissimilarity between observation 1 and 1, 1 and 2, 1 and 3, 1 and 4, 2 and 1, 2 and 2, so on and so forth. And that's why you notice that the diagonal is missing, or it's 0, right? Or I shouldn't say 0. It's a non-valid number, right? Because the dissimilarity between an observation and itself is that there's no dissimilarity, so I guess that would be 0. And that it's also symmetric, because the dissimilarity between observation 1 and 2 is the same as the dissimilarity between observation 2 and 1. Okay, that's what's happening there. And this dissimilarity can be measured in different ways, and I think that the way that the chapter deals with most dissimilarity is Euclidean distance. So these will represent Euclidean distance in our answer. Okay, so what we're going to do in parts A through E, although I probably won't call out parts A through E, is we will sketch a dendrogram for hierarchical clustering. And the question wants us to do this for complete linkage as well as for single linkage. But we will actually do all 4 types of linkages mentioned in the book. So not only complete and single, but also average and centroid. Okay, so there you go. We will look at our clustering diagram and try to find out which observations comprise each cluster. Okay, so if we break it down into 2 clusters, which observations fall into which cluster? And then we will kind of change the dissimilarity matrix, like not the values, but the ordering by which we are considering the observations, and see if and how that affects our clustering. Okay. So like I said, we'll answer these in kind of a haphazard manner here, but this is our distance matrix. Okay. And if I want to, in fact, maybe I'll do some editing on the fly here as we go along, just to help break down the steps. So here's our distance matrix, and when we run this, we see that we get this, and this replicates, or if I haven't made an error, what's in the problem. Okay, so this will be the object that we're analyzing for clusters. Okay. And now we're actually going to make our we're going to make our dendrograms. And so the way that we do that is we need to call hclust for the thing we're trying to cluster, and that's distance matrix, and we need to treat it as a distance. And we're going to do that for complete as well as for single linkages, but like I said, we'll also do for average and centroid. This next part will go in its own section. Okay. So we'll do that, and then so if I want to plot, say, complete clust, I will just plot as a dendrogram complete clust, and I give it a label there. Okay. Now in part E, this is where we kind of rearrange the order in which we are considering the observations, and so to do that, I have just taken the same code, say for complete clust, and just reversed the order. Okay, and so we get this. And so what we will see is that these two plots are the same thing, but the observations considered in a different order. Okay, so let's take a look at all this. Okay, so the left-hand column answers parts, I guess it would be C and D. And so this is what these are what the dendrograms would look like for complete and single. And again, I'm just adding on average and centroid just for, I guess, sake of completeness. Okay, this is what they would look like. And then when we change the order in which we are considering these things, we get the right-hand column. And notice that these are basically mirror images of the left-hand column, but the dissimilarity is, the same, the same among them, right? So if you go to the intersection points, these are at the same level for the left and right for the respective observations. Okay. And now the last part, or I mean, it's not the last part in the question, but the last part that we will address is which observation, if we have two clusters, right? So if we cut those trees such that we have two clusters, which observations fall in which? And so I've looked at this in two different ways. So let's just look at that here. Okay, so we have the observation 1, 2, 3, 4, the method of linkage, and then this is the group based on that method of linkage that a given observation will fall into, right? So if you read down the columns, we see that for complete linkage, observations 1 and 2 fall into one group, and then for 3 and 4 fall into the second group. And then for the rest, for single, average, and centroid, we see that observations 1, 2, and 3 fall into one cluster, and then number 4 is all by itself. Okay, and then here I've just kind of reprinted that in maybe a more readable, format here. Okay, and does this match our intuition? So if we think about complete linkage, right? So we have observations 1 and 2 in one group, and observations 3 and 4 in another group. Let me kind of blow this up a little bit. So that would be this top left one here, or conversely the top right, but we'll look at the top left. And I could certainly buy that as groupings. Okay, and then for the rest, we have that observations 1, 2, and 3 are one cluster, and then observation 4 is its own cluster. And again, I could buy that because observation 4 is the most dissimilar from these hierarchically built clusters. And so if we're saying that we have two clusters, well, then the one that is most dissimilar, from the cluster that's being built up, well, then that's going to have to go into its own cluster. So, okay, I think that is everything for this one, and I'll see you for question 3.